So, so may I introduce you, Simon, also coming from Switzerland, and we are close together. He is talking about the Switch drive. Switch is the academic network provider in Switzerland. So,
right. Thanks, Thilo. So I think I'm the third Simon today, and probably last. Switch drive can be confusing because there's switch drive and Polybox, and some of the numbers you will see look similar. And actually, our offices are probably like 2 kilometers apart with Thilo's. But it's our system is sort of the national sync and share service for Swiss education, but ETH is not using it because they have their own system. But I'll not talk too much about the use cases or business model or something that's interesting too, but more about the implementation. And actually, this talk was done by the person who's running this system and who more or less designed the current version of it, Christian Schniedrich. Unfortunately, he has some back problems, so it's very hard for him to travel. So this is actually the second time that I stand in for him giving the talk. Even a year ago, although the conference was in Zurich, he couldn't be there. So bear with me. I'm not the most intimately familiar with the system, but if you have questions later, my colleagues in the back told me they would ask him over Slack. Oh, they moved to the front. Excellent. The distinguishing quality of our system, or quality property, is that we run this on top of OpenStack, because we have a little before we went into Sync and Share, we decided that we wanted to develop an IaaS, so Infrastructure as a Service, offering for the Swiss academia. And then the demand from some user institutions came along for Sync and Share, like Dropbox replacement system. So we said, hey, we deploy this on this other thing that we're building on OpenStack. And this would be like the first demo that our OpenStack service is awesome. And since then, this has grown a bit, and sometimes we run into interesting problems. So I need to do this twice, I guess. To present me, I'm presenting Christian. So Christian works as a cloud infrastructure in our team, which is called Infrastructure and Data since January the 1st. And as I said, we have these two main services. One is Switch Engines. This is the OpenStack-based infrastructure as a service. And Switch Drive, which is our own cloud-based sync and share system. And both services are offered nationwide, but on an per organization opt-in basis, and also on a charge basis. So we actually get money from those universities that use us. It was all started 3 years ago, the development. And as I said, last year it was already presented in Zurich. And the main topic here will be to tell you what we have done over the last 12 months to improve the service. So to give you some numbers, this is about Switch Engines, so our OpenStack installation. I'm not confusing OpenStack and Owncloud all the time. So we're running the Mitaka version. It's always a game of catching up with the release frequency. And the Hammer version of Ceph. I should say that too. We have always used Ceph as like unified storage layer. Initially, mostly with OpenStack in mind. Now it's also used a bit as an object storage later, but so far, Owncloud installation just uses the block layer, RBD, through OpenStack. And this is the amount of total resources that we use for the Switch Engines service. Okay, so this is the numbers are a little too low because this is roughly a good idea of what we have. And sorry. The numbers for switch drive is very similar to what the dimensions that we heard in the talk just before Tito's talk, and also a few other systems. We're running about the same size. Gesundheit. The Surf Drive was also like 22,500 users, registered users, which is about what we have, just 24,000. The daily active users is a bit above 5,000, I think, for us. And the average volume per registered user is quite a bit lower than for Surf Drive, I think, because the total data is like 61 terabytes, 50 terabytes of active user data, plus other stuff and overhead. So I guess it's about, 3 gigabytes per registered user. I'm not sure. We also have 50 gig quota per user. That was kind of silently increased from 25 for Christmas, last Christmas or something. I don't know how many users are aware that they can store more data, but anyway. And the number of files we have is 62 megabytes, mega files, millions, megahertz. Yeah. So to recall a slide from Christian's last year's talk, our big goal was to move from this scale-up architecture where we have like large things that we need to grow to a scale-out architecture where we can just add small things to make the system keep up with increasing usage. So there were 3 areas where we in January 2016 were thinking that we were running into limitations. The first is the file system. The imagery is maybe a little tricky. So we have in our system, as I said, we have Ceph block storage, so RDB, Rados block device, RBD. And our front-end tier of Owncloud application servers, so we have about 15 of them or so, and they all have to access the same user files. And the way we do this now for performance reasons is that we have a smaller set of NFS file servers. I think it's about 6 machines. By the way, when I talk about machines, these are all virtual machines, all of them in OpenStack. And each of these 6 NFS servers mounts 5 or so 2 terabyte block devices and exports these 6 2 terabyte file systems to the application tier. And that sort of scales out nicely, but it has the NFS servers as both potential performance bottlenecks and single points of failure. When we lose one of them, immediately or after a very short time, the application servers will all stall because each application server handles files from all the users, and so each application server will run into at one point into this file server that is down. So that is a very nasty situation. So where we want to move to is to have an object store, to use an object store like CERN-box, I think, is doing with the EOS, although they're not using the object store. But anyway, a system that does not have these choke points. Similar to the database, we used to have PostgreSQL a year ago in a master-slave configuration with a like hot nearline backup or slave, and we wanted to move to a scale-out clustered database as well. And then lastly, maybe as the architecturally biggest point, we would like to go away from having a single instance of the whole Owncloud system to having multiple Ownclouds, because we know how to scale them to a point, but but then there may be like insurmountable limits. So by having multiple Owncloud instances that are sort of autonomous, we want to diffuse that danger. So how far did we get? Sorry, I don't know where to point this. So let's start with the middle case. So the database, we sort of got this done the way we would have liked a year ago. We moved from PostgreSQL to it's actually MySQL 5.7 even. I checked yesterday. I was too slow, so I could have raised my hand when Peter Borosch asked who was running MySQL 5.7. So we are. And we're running it with in a Galera cluster with max scale. So we have some scale out at least for the read rates, which is good. So that was done. The topmost line, we're not quite done yet. Moving from this NFS, multiple NFS servers based on even more RBD block volumes, moving from there to an object store based on our routers gateway layer of the Ceph cluster. That is sort of designed through, and we know how to go there, but it's not quite there yet. We're really planning to move there in early March, with the help of the people from Owncloud Inc. Or Owncloud GmbH, who we need to provide us with some missing software for the migration part, I think. And then the last part, splitting up the system into shards. No, actually, that last part is where we want to go in March. I'm sorry, I'm confusing things. Yeah, that is what we're actually working on right now, to split the system into multiple instances. And in this case, the missing part of the software is hiding this split from the users as far as all possible. Yeah, so with the about our experience moving from PostgreSQL to this clustered MySQL system, actually Owncloud has a nice migration tool for that. Apparently you can just say OCC dbconvert type and move from the old tired database to the new shiny one. The problem is that in practice, it would take, in our installation, it would have taken weeks to finish because of the amount of data, especially in the OC file cache table, which everybody who uses larger Owncloud installations knows and loves. So it is possible to do it in finite time by doing these tricks, like modifying the script slightly to skip the OC file cache, and rest of the script runs in a few hours for a database size like we have. And then for the file cache table, you like manually dump it in text form and reload it into the other database. So this is how it was done, I think. So the performance. This is when we switched over from the Postgres system, which is sort of a single node, and the nodes are pretty large. They are VMs, but they are VMs that fill up a complete compute node. So our compute nodes in our OpenStack system, they have 256 gigabytes of memory, and these database VMs, they have something like 248 gigabytes or so of virtual RAM. And of course, there are no other machines, no other VMs running on these particular servers. And also they use SSD backing store, local SSD storage on these compute nodes, which is something that we can give also to normal OpenStack users. But initially we developed that for our Owncloud databases. So we see that really after we after this changeover, the performance improved visibly, especially with the variations becoming smaller. So that sort of an indication that it handles the load better. But unfortunately, the scale-out properties were not quite as nice as we had hoped, in the sense that, like moving from 1 to 3 servers got a nice boost. But now we're seeing that as the system is growing, we add more database servers. But it seems that the benefits are diminishing, the returns are diminishing. So that hasn't been as helpful as we thought. So it doesn't look like this will move us to infinity and beyond or something. Of course, Dropbox shows, or other people like Facebook show that even with MySQL you can scale very far, but for some reason, for us or maybe other Owncloud users also, that is not quite the case in practice. So we got where we wanted to be, but it's the value is not as high as we thought. So about this sharding, as I said, our approach is that we split the whole Owncloud installation into multiple ones. In particular, because we have many organizations, a natural split will be to not necessarily have one instance for each university, but have mapping so that we can map the usernames, which are the email addresses, which include the organizational names, in a straightforward manner to instances. Maybe not a one-to-one mapping, but an end-to-one mapping or something. So that seems easy. And the instance that would do this forwarding or distribution will be the HA proxy. Yesterday, a presenter from Owncloud mentioned that they had developed this with a customer, I think that was us, as a function in HA proxy that it could do this forwarding based on cookies and values in them. So this is nice. It's fairly. It could be done fairly straightforwardly. I think there's still some limitations in how the client handled this, or how this forwarding becomes visible to the users with possible glitches, like you have to log in both to the original host name and then again to the mapped host name for the first time. But we're hoping that this can all be ironed out by early March so that we can move to this system. And yeah, lastly, moving towards the object storage as a storage substrate for the user files. So Owncloud 9.1 has this multi-bucket support. So going away from the situation which was also mentioned yesterday, that in Owncloud you can use as primary storage, as I learned yesterday, you can use an object store, but all the files of all users must be in the same bucket. And that is not something we want. Apparently this is coming in 9.1. Unfortunately, our plans for evolving the system are that we migrate to 9.0.2 or something. This is what we have tested. So it's not quite there yet for us. But the most important part is how do we migrate the existing users who have all their 60 terabytes of files on this NFS system smoothly towards the object store, without people noticing too much. And there are many other concerns, like how do we do backup? Like with the current system, we can take very simply and quickly snapshots of these underlying block storage devices. Ceph is very good for that. Deleting the old snapshots is a bit slower, but who cares? And a big unknown is the performance of the system. So we know that our implementation of Router's Gateway currently has performance limitations. On the other hand, the performance requirements don't seem to be that great in the steady state. But of course, there are usage peaks, so that is a little worrying. But we will solve this with engineering. Yeah, so I'm at the end. Here are some pointers. So you will find the code in a GitHub repository in the form of Ansible playbooks, although I have the impression that Christian is moving to a container-based deployment, like we heard multiple times today. That's also very relevant to us. I won't talk about that. These are our contacts. And also we would like to remind people about the OC mailing list in the Géant community that we have used in the past to have both technical and business-like discussions. As I said, for the questions, I hope Christian is online and we can sort of channel more deep questions to him. Thanks a lot.
So, thank you, Simon, for your talk. And are there questions around to Simon? So let me just get it's closer.
Yeah, I think the Rados gateway backend is very, very interesting. But a few tests I did, just very, very quick tests, showed that you might have a problem with the sync client in a container that contains many files, like 10,000 files or 20,000 files. This is what I showed up. Synchronization is slow, and I'm not sure it was able to end correctly on the test I did. It was real off-the-shelf hardware, nothing specialized.
Yeah, I could imagine that in these extreme cases, like I go into my switch drive directory, I unpack the Linux kernel sources, a classical case. So you have, I don't know, 500,000 files or so that have to be synchronized. It's already slow. Already, it will take, I don't know, days. Then if it takes weeks instead of days, then people might be unhappy. But yeah.
Should be careful about this. And it is very interesting to investigate in this direction, because most probably object storage is what you would like to have as a storage package.
Yeah. It seems like a good fit, and we are actually right now we are working on scaling out the front end of our object store. So up to now, we always had a single Rados gateway front end. And although there has been some intensive usage, like we have this video portal, switch tube, that serves all the video assets and images directly from Rados gateway, and it mostly works nicely. But for this, we need to have like a real scale-out front end with many Rados gateway processes, and I hope that this approach can also handle the load. Of course, assuming that a single client can make use of multiple Rados gateways via the sync servers. Yeah.
Simon, there is another
Sorry.
question here.
So you gave a rather complete presentation about the technical aspects. So I had more a question about the future strategies, if you're allowed to talk about it. So you mentioned several components like containerization, the drive, the fact that you serve Swiss institutions like ETH, EPFL, and so on. And I see many analogies to the situation that we had at CERN some years ago. And I wonder if you were thinking about providing a service like the one that was presented yesterday, Swan, for providing, since you don't have storage as a service, you have computing elements, so maybe you can put on top something that unifies everything, and you can do analysis as a service.
Yes, we are.
And share all these kind of things.
Yes, we are, but this is done, so the work on these things, like Jupyter notebooks or something, it is done from the perspective of switch engines of the OpenStack IaaS service. For some reasons, some of them organizational, because of who works on these systems in Switch. But to me, it's very interesting to see these integration opportunities. But so far we have mostly seen, well, we had a very clear mandate for building switch drive. Okay, the universities, or some schools came to us and said, please help us. Everybody's using Dropbox. We need to offer something as an alternative, and that we did. But they haven't been asking, our users want.
No, sure, because
yeah.
we are in contact with people, for example, in EPFL and the Blue Brain. They're very tightly coupled for obvious reasons.
Yeah.
And you mentioned also IBM, and I wonder if at some point all these people would like to go to IBM Bluemix, and suddenly, I mean, it's a missed opportunity somehow. But we can discuss this later if you want.
No, it's a very interesting field.
So thank you very much for questions, and Simon for your answers.